I just checked, and what I saw is it actually did what we wanted, right? So I just added here this term quadratic, some error occurred here when we catch the exception, and when we just let this run, then in the end, it actually worked out here. So we get this error message down here in the console. So if A is positive, B is 0, and C is also positive, then the parabola is certainly above the x-axis, right? So the discriminant is smaller than 0, so B is 0, B squared minus 4AC. So this is 4 times 2 times 3, and this is with a minus sign. And again, this you cannot in this case deliver the real zeros, and in this case then the error message occurs. Okay, so that kind of worked out perfectly, right? And as a homework, you can try out pimping other of these methods with try, catch, and throws in terms of, for example, catching errors that might occur in terms of the power function and any other things, or if the dimensions of the two vectors in the scalar product don't match. So there's a couple of places where we should kind of try to pimp our things here a bit more in terms of exceptions to make this really work. Okay, good. So let's go back to our slides. These were the things. So you can try it out for the vector product or the inner product or the matrix multiplication. Okay. So code conventions. So that is something I saw, or that I want to emphasize, because I saw this a lot in terms of when you asked me questions during the course, or when you asked me for help, that not all of you adhered to the code conventions that would be desirable. Okay, so if we look at this code, right? So this code here is perfectly valid, right? It initializes some matrix with a double for loop and writes some values into the matrix, right? So this is clearly a valid code, but what we can already see, it is not really very pretty, and beyond being pretty, it's also not very, it's also not very clear what is happening here, right? So this looks a lot better, right? So what we do is we have a strict indentation schema, which means that here we start writing our method declaration, and then immediately in the same line we start with our opening curly bracket of the message body, right? And if we look down and count all the curly brackets, this one here is the curly bracket that closes this opening bracket. How do I know that? Because if I take this one and go straight up with my cursor, I end exactly in the line where the opening one occurs. So this is very, very nice, okay? And although things like this might look a bit ugly to people that have a special kind of aesthetics, it's really very handy to do it like this. So here, for example, we have 2 for loops, right? So each one with an opening bracket. And if I want to know where's the closing bracket for the one at this for loop, I can go straight down and find it here, right? If I want to know where is the corresponding opening bracket to this one, I can go straight up and to the right and see it's obviously the one with the if statement. So that is a lot easier for you to just see that every opening bracket also has a closing bracket. So this is very, very important. So the indentation in Eclipse is automatically chosen to be 4 spaces. So please do not change the default way that Eclipse tries to format your code, because that is a formatting convention that is being followed by every programmer. What you should also do is to use a maximum of 80 characters per line, right? So if we look at this line here where we set the ijth element of matrix to this very complicated expression down here, right, we would not continue with this beyond the 80 characters per line, but we would just write it in the next line. And again, you would use some indentation. From a Java correctness perspective, Java doesn't care about these indentations. So the compiler would kind of not take notice of this. But if you save your own code, you should not potentially start writing this here, right? Because it's not really very clear. Just do the indentation even if you continue the line. And the Java compiler doesn't care about a new line here because this semicolon is the one that ends the statement, right? So that's why we have to write these things, because in other languages like Python, the indentation is actually what the compiler, or plus the new line, is what tells the compiler where the statement ends and where loops begin and so on, right? So in Python, these indentations and new lines do really have a significance, whereas in Java, they have not, but still we should adhere to this code formatting. What you should also do, if you compare the previous slide to this one, is use the so-called syntax highlighting that's provided by Eclipse. Because here, if you, for example, mark something like this sum matrix, you would see where all other occurrences of this are, right? And we have keywords, Java keywords being highlighted in different colors than your own names, numbers, and all these kind of things. So please use the syntax highlighting of modern integrated development environments. How should we name stuff? So, in general, the names should be as short as possible, but as long as it's necessary to be easily interpretable for anybody. So there's a compromise, right? And you should tend to rather have longer names for your variables and methods and all these kind of things, because otherwise it becomes increasingly hard to actually know what a variable is intended for, right? So any denominator for a variable, for a method, for a class, for anything should indicate its purpose as clear as possible. Second, always use English, right? Never use German variable names. So I kind of deviated from this by calling the variables at the very beginning Horst and Heiner. This was just to make it a bit more abstruse, that it would more easily stick to your brain. However, always use English variable and methods and other names, right? And please only use the letters from A to Z, uppercase A to Z, and the numbers from 0 to 9, or the digits from 0 to 9, right? Of course, except for constants, so static finals, where we would deviate in terms of the underscore, right? But any normal thing, such as a variable row index, column index, is valid, or a method copy file, should tell easily anybody or indicate what the purpose is. Methods and variables should start with a lowercase, and internal words should be capitalized. And Boolean variables should ideally start with is, right? So this Boolean is valid, right? Whereas classes and interfaces adhere to the same pattern, but start with an uppercase letter. So please remember to do this. Methods and variables start with lowercase, classes and interface start with uppercase. And constants are an exception. They're all uppercase, and internal words are kind of separated with an underscore. So static final int min allowed value 42, whatever this means, right? So this is a standard, and you should adhere to the standard. Commands and documentation. Although I did not do this a lot because that would take too much typing time in class in my examples, you should actually make use a lot about commands, right? So here, for example, let's assume we had this non-exception pinned version of factorial, where we still had this, yeah, not very reasonable case if n smaller than 0, return -1. So this is not a good idea, and since we know how to deal with exceptions, we can do that a lot better now. But unless you you kind of really did this properly, you should at least comment this and write something -1 is intended as an error code, and please fix me in the next iteration. It's not very good style, so you should do this right away, but this is one way to use a comment, right? And please use comments a lot. So like more luxurious comments are so-called Java doc comments, and they start with a slash double star and end with a star slash, right? And the lines in between are started with a star. Now what we can see is that, well, these are also comments, and you might as well use them, but what Java doc does for you is to, if you write a couple of classes with a couple of methods, Java doc is able to automatically create a documentation HTML page where your whole code and all of the methods and classes and their intended usage and the parameters and the types and what they're there for can be put into a single website. This is very convenient for people that just want to use your code instead of just wanting to know how it's actually done, right? We will later get an example of this, right? So here, this factorial method, there is a string that says what this method does. So it computes the factorial, f of n is n factorial. And with that add param, you are able to describe what the parameters, the respective parameters of the methods actually do, and what the return value means, right? So this is something that is very nice. If you want to know more, go to the respective documentation of Java doc. Just Google it, or in the in our Java tutorial. So this is that. So please adhere to that, because other programmers would really rely on it. Last thing for today, we will talk about the Java class library and about generics, right? Now, as we will see, generics is something that has been invented, I think, somewhere around Java 6 or something. And of course, we're talking about Java 13 at this moment. So there's a couple of new things happening in Java since the last 3-4 years. But I think generics is at least something we should talk about here. And the other things are maybe not that super necessary, but yeah, well, generics is. This is the Java class library. So in the beginning of our Java chapter in this lecture, we said, why did we choose Java at all? So one aspect is that Java is able to run on almost any device, Mac, Linux, Windows, whatever, right? The other argument, which is also true for a lot of other programming languages, such as Python or C# or Objective-C or even C++, is there is a very large library of classes available that for all kinds of purposes, for networking, for drawing stuff on the screen, for popping up windows, for programming radio buttons and everything that you could think of, right? So up to now, we did not really pay a lot of heed to this Java class library because we investigated only basic programming tools for programming your own classes. Now, in most of the cases, you as students of management and technology will solve your more complex problems not by programming it all for yourself, but more like using methods and classes that other people have written. So if you have a more complex problem than the ones we've used, our toy examples, we used specialized classes of a class library. And the class library that comes with Java has hundreds of thousands of classes, and forms an abstract programming interface. So what this means is, in the end, I don't care about how a class or the methods of the class are actually implemented, as long as I know what the respective method does, how to access it, what the parameters mean, and what I can expect as a return value. Right? So that's how these things look, right? So here's an example for Java 7, but of course Java 13 looks very similar, right? And something equivalent exists for all modern object-oriented languages like C#, Objective-C, and so on, right? So if you go to this, what you see here is the right website, or might be the right website. So we have three parts here. So here's all the packages in the upper left corner. Then here we have an alphabetically sorted or lexicographically sorted list of class names. And you can see there's a lot of things. User exception, this is a special exception. And for example, utilities, validator, I don't know what these things do, at least not for all of them. Here, I kind of clicked on something that is called vector, right? Vector is a dynamic array, right? And if we click on this, here we get an extensive description what the class vector does. Obviously something that has these pointed brackets, which we have not yet talked about. But here it says public class vector extends something and implements a couple of interfaces, right? And then here's a textual description. And very nice is, if you scroll down, it tells you all the fields, all the attributes that an object or a class, this class might have, right? If it's static, what the constructors are. In this case, we have 4 constructors with increasing level of professionalism, right? So there's a default constructor, which just gives you a vector object. And here's a description of all the methods that this class offers, right? Now, as I said, a dynamic array. So you can store elements into vector and retrieve them back. The advantage compared to standard arrays is that a vector is something that is a dynamic array. And we will talk about this in January a lot more. So if you want to solve a more complex problem, the first thing you should potentially do is to Google, right? How should I, for example, open up a window and inside this window show a photograph, right? Then you should Google for show photograph in window Java. And hopefully in Stack Overflow or in the Java tutorial or in any other nice place, you would find a piece of code that you can use, right? And in that piece of code, this piece of code might use certain classes. And if you're not 100% sure, or if this code does not 100% do what you want, but something slightly related, you might alter the code and then go to the respective documentation of the classes and see what they do, how they are accessed, what the methods do, and so on. So this is very, very nice, right? Now, something that we have already mentioned is packages, right? So if we go back, these are all packages, and you can scroll down and you can see here there's a lot of packages, right? So hundreds of packages. So for example, here we can see Java Applet, that's an older technology that is not much used, or Java Abstract Windowing Toolkit. So this is all alphabetically sorted, right? So packages are hierarchically organized. So there's this Java upper level hierarchy, and below that there is Java Lang, which contains the core Java language elements. Java Net contains anything that has to do with networking, and so on and so on, right? And if the package was provided not by the Java core company, let's call it, by Oracle, right? But for example, here by the W3C, the World Wide Web Consortium, which has the URL w3c.org, then in reverse order of the corresponding URL. So that is org.w3c, and then the hierarchy of things that they publish in their packages. In this case, DOM, this is a document object model, events, document event. So while parsing a document with this W3C standard, you can use all these classes in this package. And before you can use a package from another package, you have to import it, right? All the classes from Java Lang are automatically imported, but if I, for example, want to use any class that is in java.net.url connection, I have to write this import statement before my actual class declaration, right? And I can use wildcards. So I can say java.net URL connection. This is not a package. Is it? No, it is, sorry, I was talking shit. So java.net is a package. Java.net.url connection is a class, of course, right? And java.lang is a package, and java.lang string is a class, of course, right? So the package is java.lang, and the class is java.lang.string. Right? So if I want to use URL connection, I will have to import it. I could as well have written import java.net.star. So this is the wildcard. So I'm importing all the classes in java.net, right? So this is that. So again here, and of course the package down here is org.w3.dom.events, and the class is document event. So in here, in the upper example, these are all classes that are in the respective packages, right? It's just a means to organize your classes. And if you want to use the Java class library, then you will have to get familiar with these imports. It's just that keyword import and the respective class. Now, this is next to the last thing in this Java chapter, generics. So, as we've seen here, let me just go back. This vector has this very strange thing here with these pointed brackets, right? And this is what we call vector is a generic class. So, the thing with generic classes is that these classes may be parameterized with other classes. Ooh, what is that, right? So a typical example for this is classes that implement data structures. This is, we will discuss in January, but it's an organization form for data in terms of efficient processing with algorithms, right? So a graph is a data structure, a tree, a list, a matrix, all these kind of things, okay? And of course, a data structure should be optimized towards the things that are stored in the data structure, right? And if we do not do this, then we will have to write a lot more code, right? So let me just show you what I mean. So without using generics, if I want a dynamic array that I do not have to provide an exact size for when creating it, I can, for example, use the aforementioned class vector and declare me a variable non-generic vector, which is a vector, right? And here I do not use any kind of generics. Now I can happily store stuff in that non-generic vector. I can store a bicycle, I can add a string, I could add whatever I want, a little bee, right? I can stuff everything into my vector. So the first thing we see is if a vector is not used with generics, it's more like a dark attic. You can throw in everything you want. So this is different to an array, of course, because the array we need to especially bind to a type, right? Now, the vector also provides methods not just to add something, to throw something in, but to also retrieve it back. And this retrieving back is done with the get method, right? So I can say non-generic vector get the thing at the first position, so the thing with index 0, right? Now, the what type will that thing be that's at the 0th position? And the answer is, if I don't use generics, I don't know. So what does that mean, I don't know? The method get will have to return some reference. A reference of what type? Well, the most general type there is in Java. What is the most general type there is in Java? What class is at the root of the class hierarchy? This is a class that all the other classes inherit from. This is the most general thing we could think of. Now, this class at the root of the class hierarchy is called object. Okay, so the stuff that's being returned by this get method must be of that general kind. Why? Because we don't know, right? We don't know. So if this get would return a bicycle, then it would, of course, be incompatible here with that string. And if it would return a string, it would be incompatible with this bicycle. So the least common denominator, or the smallest common denominator for all the objects, is object, this class called object, right? Now, I could as well say, but I want my bike back. So I would define myself a variable of type bicycle, and then I will have to, for each possibility, check if what I get back is actually a bicycle. So in this else part, I might say, if what I get here, type unknown, is instance of bicycle, then I can perceive this thing as a bicycle, so I can typecast it to a bicycle and then store it here in bike. Right? So I have retrieved my bicycle as a bicycle back out of the vector, but I would have to take this detour over checking, is it a bicycle? Is it a string? Is it, I don't know, an X, Y, Z? So I will have to check all of this. So the code gets very long and very complicated, and this is not really what we want, right? So how do we use vector with generics? Well, I can say I declare my now generic vector, which I call bicycles, by writing this parameterization class into these pointed brackets right after vector. So vector of bicycles, as we read it, is just what it is. It's a vector of bicycles, and this variable is called bicycles, right? And I declare it, or I can initialize it as a new vector of bicycle, right? So I would parameterize my old class vector with my parameterization class bicycle. So that means this vector of bicycle now can only take up bicycles. If I try to store a string or a bee or a hornet into this vector of bicycles, I would get an error. Right? So in this case, the parameterized, the generics version of vector is closer to our original concept of an array, right? What is the advantage? So it's seemingly we lose some flexibility. With the non-generic one, I could throw in what I want, but when taking it out again, I had to check what it actually is, right? If I use a generic version of vector, I know what I get out with get is always of that base type that parameterizes that. And this is a great advantage, right? Because I don't have to write all of this instance of if checking code, right? So this is very, very good. And if we go back here to this, E is just the base class. So E can be any class you would want, right? Bicycle, bee, hornet, whatever you like, right? And this is very convenient. Last thing, if we want to put stuff into such a generic or non-generic vector, so that's a Java collection subclass, right? If we want to do this, obviously, this thing has to take reference type variables or references into it, right? If we want to put an integer into it, I think I would have to check how this is possible. But in terms of generics, it's certainly necessary to parameterize it with a class. Now, if I want vectors of integers, int is a primitive type and not a reference type. How could I handle this? The answer is with, for example, with wrapper classes. So for each primitive type, there is a corresponding wrapper class. And here it's called integer with a large I, right? And this is a very simple class that has only one attribute, that is the int value that is being stored in this object, but now it's a reference type representation of an integer, right? And instead of just writing integer some integer's new value is new integer 723, I can take this short way to write it and say integer some integer is 723. So this is just an abbreviation for this, right? And this is called boxing. So if you want to use your primitive types in something like a generic vector, you can do so with the help of these wrapper classes. So what we have seen so far, to wrap this all up, objects have attributes and methods, right? They correspond to state and behavior, right? Objects are instances of classes. Classes form a hierarchy via inheritance, and objects' behavior may be polymorphic. Now, what we've seen is, in object orientation, we should use the right level of abstraction and keep all the implementation details hidden, right? So the flower in our last programming examples can choose how it wants to represent its pollen that it really provides, and it hides that details from the rest of the world that are just using the behaviors of the flower. So this principle is called information hiding, and the purpose of this is to not create spaghetti-like dependencies towards all the implementation details that you might otherwise want to know and use, right? This is this principle of abstractions. So objects, if it's not necessary to do otherwise, should hide their attributes and grant access to them only via getter and setter methods. And concerning the methods, only their signature, that is the name and the parameter types, and their semantics, in terms of a textual description in Java doc, for example, should be interesting for other objects and not how they are implemented. Right? So I'm using the method just by what it takes as an input feedback. How it does it should be of no concern in most of the cases. So methods should avoid any side effects on other objects if possible. So most of the methods that we have used so far, like factorial or exponential, just have a clear input-output behavior. Right? So you have your inputs, then this does some computations, and it does some outputs. Now, in terms of the bees and flowers, we have seen if I want to let the bee collect pollen from a flower, then I would have to pass the reference to this flower, and inside this collect pollen in the bee, I would call this yield pollen in the flower. So a method might as well call several other methods. And, of course, if I give some object references, it might change these objects without someone calling that method automatically knowing it, right? So if it has a clear input-output semantics, then I know what happens. I give something in, I get something out. If along the way this thing changes 50 objects and changes their state, and I don't see that, then this is a side effect which is easy to handle, and if possible, this should be avoided. It's not always possible, actually. Okay, so this is it, ladies and gents. So this is it for the Monday 23rd of December lecture. I wish you all a very Merry Christmas, a Happy New Year, and hope we would see you all in good health in the new year. So, see you.